We're dealing with compressions and stretches today. And first, just like before, let's deal with vertical. And actually, I think I'm going to write down the notes for horizontal today, but I probably am only going to deal with vertical today, okay? So what happens with a vertical stretch or compression is you see it in the same spot always, and what happens is we start with the graph f of x, okay, and it has ordered pair just like before, an x coordinate and a y coordinate. And what we do to vertically stretch or compress something is we put a number in front multiplied in front of the function. And so I'm going to call that c again, and c times f of x. Okay, so I want you to think about this word vertical. Which coordinate do you think that a vertical stretch is going to affect? The x or the y? The y is the vertical one, right? So if you were plotting, those little line segments like we would do, you would leave the x the same, and then the y you would multiply by whatever that number was. Okay. That's how that works. So you see a value out in front. Okay. Now, here's how you tell if it's a stretch or compression. And with the y's, with the vertical, it's kind of easy. With horizontal, x is a liar, so it gets tricky. Okay. What would happen to a number if you multiplied by 3? Would it get larger or smaller? Larger, okay? So when I'm doing these, if c is a number that's greater than 1, that is a vertical stretch. So if you're multiplying by a number that's greater than 1, that is a vertical stretch. If you're multiplying by, let's say I said, hey, multiply by 0.2, what would happen to that? It gets smaller. So if you're multiplying by a number between 0 and 1, okay, think decimal fraction, but it's got to be between 0 and 1, it's going to get smaller. We're going to call that a compression. So if c is between 0 and 1, we'll call that a compression. Okay. All right, now let's write down our horizontal transformation. Okay. And I'm going to write a key phrase down here that you should have heard me say a couple days ago. When we start putting things in with x, x is a liar. Okay? Remember how when I put in the parentheses on the opener today, x plus 2, but it moved the graph left 2? Okay? It's the same thing with multiplication. When you see a multiplication in with the x, it actually means that the x's are being divided or multiplied by the reciprocal. Just to review that concept, isn't dividing something by 2 the same as multiplying by 1/2? Okay, so that's what I mean. Like, if I see a 2x in there, it's going to actually divide your x coordinates or multiply them by 1/2, by 2. Same with other numbers. All right, so here's how it works. So this time, you are going to see this value inside the function with x. So it's not going to be out in front, it's going to be something times x inside. And whatever this is, you're going to take the reciprocal. If you don't remember what the reciprocal is, I can refresh your memory when we're done writing this down. So you're going to then take the reciprocal of whatever this number is, and that's what you're going to multiply by your x coordinates. The y coordinates are going to stay the same. What that means is this. This number, then, if it's bigger than 1, you're going to be actually dividing the values by that. That's going to make it not a stretch anymore. That's going to be a compression. Remember, x is a liar. And when you're dealing with numbers between 0 and 1, that's going to make it a stretch. Okay, so the key here is whatever that value is, we actually take the reciprocal of that, and that's your kind of your factor. Okay. I'm going to let's at least look at an absolute value to start. So this time I'm going to pass these back so you can see how far we get to it. Okay. So because compressions are, especially with the horizontal business, again, are probably the trickiest. I think even when you move up to pre-calculus and AP calculus, my students, the thing that they struggle the most with are the horizontal stretches and compressions. So if you struggle with that over the next few days, you're not alone. We'll keep working on it. The horizontals are easier because it's what you would think. So do you see that 2 out in front? Okay. Looking at what we were talking about, that looks just like that, doesn't it? And we would hopefully agree. See, that number is 2. Isn't that a number bigger than 1? Agreed? Okay. So the transformation that's occurring here, then, let's do that first, is a vertical stretch of 2. Okay. So what I'm going to do to find my new points then is I'm going to take my old points and I'm going to multiply them by 2. We would all agree this goes through negative 1, 1, 0, 0, and 1, 1. Isn't that the key points we've been talking about? All right. Let's go ahead and take our y coordinates, and we're going to multiply our y coordinates by 2. Are you ready? Okay. What does that become? What's 1 times 2? 2. So now I have the ordered pair, negative 1, 2. Let's multiply 0 by 2. What's 0 times 2? Not 0. So it doesn't change the 0, 0. Let's multiply we're doing the y, by 2. What does it become? 2. That's going to go the point 1, 2. So do you see how all of the y coordinates got bigger? All right, let's plot them. So this -1 used to be there, now it's stretched up to 2. 0, 0 stays the same. 1, 2 is right here. And we draw still our same shape. Okay. So it looks like that got narrower, huh? Think of the slopes, they got steeper. It stretched those slopes. Okay. What else does it look like to you? What's another way that, just if you didn't know what we talked about in our notes today, how else could you describe what happened from the absolute value to the blue graph? Any ideas? Does it look maybe like another way of thinking of it is it got squeezed towards the x-axis as well? Can you see that? Okay. All right. We're not going to do example 2. Let's just glue this one in. And then I'm going to give you another piece of paper. We're going to just do one off of this. And once again, the one we're going to do is a vertical one. Okay, so you might wonder how can you tell on a parabola if it's out in front. You're not going to see a parentheses if I consider it out in front. Just look below this. Do you see how when I do it this way, the 1/2 is in there? So this is considered out in front, which is our first one, which is a vertical stretch or compression. Okay, so the number I see out in front is a 3. Is that a number bigger than 1 or between 0 and 1? Bigger. So what kind is it? Stretch. Good. So this is going to be a vertical stretch of 3. Okay, I'm gonna show my 3 key points, but we remember, do you see the shape of this graph? Okay, I'm only using 3 points because I don't want you to spend a lot of time graphing a million points. But just keep in mind it's still a parabola, so it's gonna be a steep one, but it's gonna be U-shaped. All right, so we're gonna take our xy's, which right now, okay, those are 3 key points. -1, 1, 0, 0, 1, 1. And now what am I going to do? Multiply the y coordinates by 3. Okay. So on that top one, 1 times 3 is 3. This is going to now have the ordered pair -1, 3. 0 times 3 is 0. So this point stays the same. And then 1 times 3 is 3. Right, that goes to that. All right, so I plot my new points. I guess I should have done the original ones in a different color. There's my original ones. All right, so now there's my -1, 3, my 0, 0, and my 1, 3, and do a careful job of making this curve at the bottom, okay?